Welcome everyone to our 2:30 press conference, which is about nuisance flooding related to sea level rise. We've called it "The Waters There Are Rising. What does the historical past warn of in the near-term future?" And our two speakers will speak in this order. William Sweet, he's an oceanographer at NOAA's National Ocean Services Center for Operations, Oceanographic Products and Services in Silver Spring, Maryland, and Jayantha Obesekera, who is with South Florida Water Management in West Palm Beach, Florida.
Good afternoon. I'm William Sweet. I'd like to recognize my co-author, Joseph Park, a new paper we've just released today, From the Extreme to the Mean, Acceleration and Tipping Points of Coastal Inundation from Sea Level Rise. This paper is concerned with increased nuisance coastal flooding around the United States. It describes the process in which an event, an extreme high water event, seemingly once quite rare, has become commonplace today and is projected to become even more so, growing in the impacts growing over the next several decades from local sea level rise projections. The basis of our study uses NOAA tide gauges. There are over 200 long-term tide gauges around the United States and including the Great Lakes. They measure local relative sea level change, includes vertical land motion associated with any land substance or human uses that combined with global rise of the ocean result in the change, that long-term change that we witness here at the coastal edge. These sites have been in operation for over a century. Here shown is the San Francisco site. Nuisance flooding. The Weather Service has established a proxy on our tide gauges from years of impact monitoring. Jones Street's flooding again, the seawalls overtopping. When they witness these events, they go back and look at our tide gauges and see what the elevation read. And so they establish a nuisance or a minor level, a moderate or a major. I went and looked at the records and see when the nuisance level has been exceeded, and I make these counts. It's an unbiased measurement over time that let us know of local impacts are occurring. The frame of reference is today. This is where we live, and our infrastructure is already in place. Around the country, I've looked at 27 long-term tide gauges with over 50 years of record. The infrastructure becomes vulnerable to coastal flooding somewhere between 1 and 2 feet above high tide, average high tide today. That's our current frame of reference. It's looking down. As Bob Dylan's B-side hit might have read, sung the tides they are changing. We know that the combination of rising seas and sinking land has decreased the height of our infrastructure above high tide. Then, such an event might have occurred during a big storm. Now, sunny day nuisance urban flooding is becoming more common. Sea level rise. We know it's occurring, but what's of surprise is this accelerated impacts that we're finding, the nuisance level along the east and Gulf coasts. The west coast, it's not as steady, sea level rise. It jumps year to year with El Nino and La Nina, but nuisance flooding is still increasing. As long as sea level is going up, so too the events frequency, oftentimes dramatically. Shown here is highest daily tide at Norfolk, Virginia, over a course of a 5-year section, relative to today's nuisance level. I would add each nuisance level is at a different elevation at each location, dependent upon the natural drainage and characteristics of that area, and also would reflect any mitigation or human changes that have occurred to prevent such impacts. So, back in the 50s, here's where sea level was. There were some storms. In the 80s, everything is rising. And now we get to the 2000s, 2010, where, yes, there are a few big events here and there, but that's not primarily what we're concerned. We're interested in these lesser events that now are starting to cause impacts, and you can see just the normal lesser storm, king tides, are causing impacts. So if I look at a 5-year average of impacts, let's say in Norfolk, you can see that it's not a smooth, gradual increase. They're growing quite rapidly. And it's emerging flooding crisis, actually, that we have. This was results of the NOAA technical report that we review more in depth in this paper, but you can see the large increases in percentages that's been occurring at many of our tide gauge locations around the country. Upwards of 5 to 10 times as more today than we had 50 years ago. What does it look like? And when is enough going to be enough? Many different images of what nuisance flooding might look like in your community. Overtopping of a seawall, water in the streets, storm water systems that are effectively diminished in their capacity to remove water, roads closed, warning signs. So we're looking at 30 days per year with nuisance flooding. That might be a time when changes will need to really occur in earnest, maybe beforehand. So what we'll look at is, if this is a situation in Norfolk, how much actual sea rise needs to take place to when we might expect to see 30 days a year? It's not that much, maybe less than a foot. So we've used some local sea level rise projections recently put out by a researcher, Robert Kopp from Rutgers University, that was based upon the recent findings of the IPCC. These global rise scenarios by 2100 varied from 0.5 meters to 1.2 meters under certain conditions, 1.5 to 4 feet approximately by 2100, a range of projections. The local sea level rise that would occur would reflect any local movement, rates of subsidence, and any regional factors that might cause you to be slightly higher than lower than the global projection. Sea level will rise, but it won't be a bathtub. So if you look at Norfolk, on the left plot, that would be the number of events per year, historically. And then under these 4 different scenarios, you can see projected in the future at what point they might cross the 30 days per year tipping point. And you can see the span there of the decades, somewhere between 2020 and 2040. And if you would carry that projection out in time, you can see at some point in the next 60 or 70 years, but definitely by 2100 under most of these scenarios, you're getting daily nuisance flooding. So if we look at San Francisco, a little bit more interannual variability that we pointed out, you still see a similar type pattern. In the next 15 or 20 years or so, you should be crossing this tipping point. And projected out to the 21st century, you get to the point where you get to near daily nuisance flooding. Under all the scenarios, from 1.5 to 4 feet by 2100. So we've made a table that highlights these locations in our study. And you can see the actual elevation where the infrastructure starts to be exposed to this nuisance level flooding. And then we give you a time horizon based upon all 4 of the projections, the highest projection and the lowest projection, and we show the dates by decade. We don't try to singular out any particular year. It's honest to the data itself. And you can see by the middle of the century, most locations will have crossed this tipping point, again, regardless of the sea level rise projection itself. These results are important critical for effective risk management. They're in our planning horizon now, and this should be considered as we move forward for smart planning and growth. Thank you.
Good afternoon. My name is Jayanta Obesekara. A lot of people have trouble pronouncing my name, so you can call me Obi. That's how I'm known in South Florida. I'm the chief modeler for the South Florida Water Management District, where basically is sort of ground zero for sea level rise impacts. And I'm going to show you some evidences of problems that are already caused by sea level rise. Examples of what Dr. Sweet talked about in South Florida, and some of the work we are doing to address the issues that we raise. Basically, I think Dr. Sweet already mentioned this. As the mean sea level increases, the extremes increase with it, and you're going to have more and more problems with the extremes in the future because mean sea level is projected to increase. And the projections, if you listen to many talks in this conference, historically they have been mostly linear, but with the ice sheet discharges and other effects in the future, the mean sea level is expected to rise not in a linear fashion, but more like a quadratic or nonlinear, or the sea level increase will accelerate. And that's the big concern. As that happens, you'll have more and more impacts of extremes and more frequent extremes, as Billy talked about. So I want to show you some of the pictures that are already happening in South Florida. This upper left corner, it's a perfectly sunny day. The streets in Miami Beach are flooded. We call that sunny day flooding. And this woman is trying to figure out what is going on. There's no rainstorm that's causing floods. Basically, water coming through the storm sewer system during high tide into the streets. The one on the upper right, basically showing, again, tidal flooding the front yard of this person. Obviously, that's probably what nobody should do that. It's not a good quality water. And the lower left corner, you have 5 blocks of A1A, major highway in Broward County, that got washed off about 2 years ago. And this video, actually, this you're seeing, I took that video in Miami Beach last year, and you can see the flooding of streets. This is the type of nuisance flooding that Dr. Sweet talked about. It's already happening almost every year. Miles and miles of streets are flooded. People cannot go to grocery store. They all have boots. So it's already happening in some parts, particularly in South Florida. As I mentioned, the sea level is projected to accelerate. This is projections from the National Climate Assessment and also U.S. Army Corps of Engineers. So the concern is that you're going to see more and more frequent events like the one we just saw. South Florida has other challenges. It's very unique. It's very flat, like in many other parts of the country. We have this coastal infrastructure. You see the coastal water control structures. They were designed and built in the 1950s by a federal project. But they did not consider the type of sea level rise we have experienced or we are going to experience. And see, these water control structures, basically we call them salinity barriers to stop salt water coming into the canals and also provide flood protection. There are places we cannot operate them because sea level has already risen to the point that if we open the gates, the salt water would come back into the canal. And then obviously the Miami Beach example you show. Basically, when it rains, you open the gate and let the water out, but now when the higher sea level, you cannot open the gate because the water would come back into the canals and basically create a potential for flooding in some of these areas. We have addressed this in a couple of places. You see this old structure to the left of it in near Miami Airport. We had to put new pumps to pump out the flood waters because we cannot open the gate with the higher sea level. This is the type of solution that can work in some places. These are very expensive, but that's the type of adaptation strategies. The other issue is the higher sea level. The South Florida, Miami area, the rock is very porous like Swiss cheese, so you can't build the levees or walls like the Dutch would do and stop the water. Water would come underground and contaminate the well fields, and that's a major concern for South Florida area. We have started mapping the saltwater front. You see on the both graphics, yellow or red line. You see the dots are basically, they are the well fields that provide water supply to communities. And some of the well fields are very close to the saltwater front. And with the acceleration of sea level, we are concerned that the well fields will have to be abandoned. Another issue is basically the inundation of the Everglades National Park. Some parts of it and all the questions that around that issue of flooding. Basically, the organic peat would interact with salty water and would collapse. So there are questions like, why are we even trying to restore the Everglades if it's going to be flooded? And we think it's important. Everglades restoration is a effective mitigation strategy, because you send more water to build up the peat. So the reason I'm here is to talk about the science behind it. What we can do in going forward. We need to come up with ways to deal with what we call non-stationary behavior. We don't teach this, or we didn't teach this in schools. We have to teach the new generation of how to deal with this non-stationarity. And we have used this concept of flood return period, but it is no longer valid because the future climate is changing. So we have come up with ways to design or plan the coastal infrastructures or seawalls through the type of science that we have. We are going to discuss here at this meeting. So basically, we can provide information as to what should we design for today in order to have the level of protection for the next 30 to 40 years. So that's where the science is coming in, how to communicate to the local managers on dealing with this non-stationarity. Anyway, with that, I will stop.
Okay, we're ready to start with questions. Do we have any questions here from the floor?
Hi, Mary Miller at the Exploratorium. The nuisance flooding in San Francisco, I assume, is almost all tide-based, like king tide.
Yes. Again, it's going to be at some elevation above the tide gauge, and for the most part, the West Coast is really driven by the tide cycle itself. So you have these king tide initiatives that really can pinpoint the day based on our NOAA tide predictions, saying this is the 2 to 3 day window when your predicted tides will be highest, and indeed, you can usually see impacts associated. There could be other instances that would register at our tide gauges. For instance, last week I know you had some pretty severe storms. So we would count any instance above some elevation at your tide gauge. Sometimes it will be more noticeable, the impacts, and sometimes they may be less so. But nonetheless, it is sort of the emerging threat. There's just not much distance between your infrastructure and the water level surface.
Do we have more questions?
Harvey Leifert, freelance. Not to be too gloomy, but I think we've all seen maps of southern Florida showing it underwater in the next 100 to 200 years or some figure like that. And I'm wondering if your organization, Dr. Abeysekera, takes this seriously, that at some point we're all going to have to leave anyway, or if you really think there are mitigation strategies that can keep South Florida as a place where people live and work and are happy.
That is a good question that we get very frequently. The way we address in our organization, we need to address the next several decades. So I think it's premature to talk about retreat at this point. We do know that at some point the sea level rise is going to be in the order of several feet. In that case, large areas of South Florida might be inundated. But in the meantime, the question is the timing of when that might happen. And there are a lot of uncertainties in models. As you go to all the talks here, it is very difficult to predict when certain level will happen, and that's why we use a scenario approach. So we think that we need to solve the problems for the next several decades. For example, Miami Beach is spending large amount of money to put pumps so that they can pump out during this tidal flooding, and they're in the process of trying to raise the seawalls. I think in the next several decades, that's going to be the solution. I think we need to watch where the data is going and then decide at what point we need to talk about retreat. But I think it's premature at this stage because people are not going to in certain areas, and I think it's our responsibility to solve the problems for the next several decades, but not lose the sight on the long term. There are some solutions that we don't want to be preempted in the long run in implementing those, so we had to watch some of those long-term issues. We think water conservation is a solution, so there are some adaptive risk management strategies that we are trying in the meantime.
Further questions?
Hi, I'm Andrew Friedman with Mashable. There had been a report earlier this year, I think from UCS, about nuisance flooding and raising the profile of that problem. How does the new paper that you have in Earth's Future today relate to that or differ from that in terms of its conclusions or methods?
In terms of the methods, first we sort of go back to more of a historical characterization of the past and mathematically describe the accelerating rates that some of these communities are facing, and showed, based upon tide range and based upon certain levels of storminess and sea level rise, that you can actually use some of these methods to make sense of your situation even if you didn't have a long-term tide gauge. In terms of projections, we used the latest from the IPCC that had been incorporated by, as I said, Robert Kopp, that show that the sea level rise is not projected to be uniform. It's not going to be a bathtub. And we use a set of four scenarios, essentially, to show that regardless of the scenario themselves, the range of impacts are actually, in terms of frequency and timing, are fairly similar in terms of what will be projected. So in an area that you might feel that you want to project 1.5 feet by 2100 versus an area that you feel that 4 feet might be a better estimate for your location. In many of these areas, the results will show, in terms of a frequency of events that will be impacting you, there's not that much difference between the four. It's not so much the mean that we are concerned about, but it's the frequency of these lesser extremes that really will start to force some mitigative strategies and responses.
Any more questions from press? Yeah.
Andy Ferguson with the Center for Climate Protection. I've heard some anecdotal discussions about the situation in South Florida that includes discussions of vacating first floors of buildings and other, somewhat maybe floating buildings, things like that. Has that entered into the active discussion stage, or is that still pretty much, people talking at this point?
Some of those are in the active discussion phase. For example, in the Key West, I think there are some local policies that the first floor, you need to expect flooding of the first floor in certain areas. I think that is happening, but all along the South Florida region, that is not an active discussion at this point. But we have this concept called adaptation action areas, actually established by the state legislature, that the communities are free to come up with land use regulation policies according in their comprehensive plans to implement policies like that. So I think in the future there'll be more and more discussion about when you rebuild a certain community, they have to think about raising the roads and implementing, solutions like that. I think that will come up in the future. And the insurance industry also might get involved in that discussion as well.
Do we have other questions?
Hi, Brian Kahn, Climate Central. My question was just, with the projections that you put out now, it seems to have stepped up on the previous work that you've done. And do you see that these projections are now actionable things that local communities can use? And if not, you know, what kind of steps do you think need to be taken to make this kind of information more useful to people?
Good question. I think the power of these types of projections, there's basically showing, carrying forth the trends that we've already observed, and they allow the communities to at least get a sense of locally what is projected to be potentially likely to occur in the area, so that they can, we can build products and services to deliver, first of all, to these communities based upon a real-time observation network of tide gauges, so that they can actually see sort of what trajectory they appear to be on. So, for instance, if they find that they tend to track, let's say, a middle of the road scenario 2 feet or so by 2100, they can actively participate and see on a year-to-year basis of how impacts are actually playing out, and to make the right decisions about the next decade or so based upon the current trajectory that they're actually experiencing.
Do we have more questions? Okay, I think that finishes this press conference. Thank you very much, speakers, and thanks everyone else who came. And that wraps it up for press conferences at the fall meeting this year.